think we should be pretty good to get started. Any latecomers can just ask questions if they need to. So yeah, Harry, take it away.
Okay, great. Thanks everyone for coming. I'm super excited about this. This is something I've been kind of living and breathing for the past few months, and it's so fun to get to actually talk about it with y'all. So just by way of a brief introduction, I'm Harry. I'm one of the founders of Gadget, the CTO right now, and I wanted to start Gadget basically for myself, to do kind of what I think y'all are going to do if you participate in the hackathon, which is just to be able to build cool stuff really fast and kind of get to spend my time on the hard or the interesting parts, like the new technology or the scaling, or building something that customers really want, as opposed to kind of the BS of traditional app development, which is setting up servers or fighting with the framework, or one of the kind of countless myriad aggressions against developers' time. So what I want to cover today is how to use Gadget for building a kind of emerging class of application, which is AI applications powered by large language models. So just as a brief agenda, we'll do a quick intro to what the heck Gadget is, what the heck large language models, or LLMs for short, are, talk a little bit about the OpenAI API, and then we'll build an app. So if you're unfamiliar, what Gadget is two things that have been smooshed together. It is a JavaScript full stack framework. So React on the front end and Fastify on the back end, and a lot of kind of marriage between them. And in addition to this framework, it's a hosting platform that framework runs on. You can think of it kind of like Vercel, but full stack. And when I say full, I mean all the way down to the database, to the kind of cloud resources that power it, and all the way to the top, which is the pixels that your users see. The reason why we think this is a good idea of kind of marrying a full stack framework with a hosting platform is that the two can kind of know about each other and accelerate you a lot. So when we get into the app building process, I'll kind of point out all the things that we don't have to do because these two things know about each other. Yeah, and the goal is just to make it faster for me and for you. When I say full stack, I really mean full stack. And so Gadget includes kind of facilities for storing data in a database, like querying that data, aggregating it, filtering it, sorting it, whatever. It includes facilities for rendering HTTP responses or images or PDFs or whatever with serverless functions. We auto-generate a GraphQL API for the data in your database, and so you're able to kind of access that, say from a Shopify storefront or from a server-side script somewhere else, so on and so forth. And then Gadget can also host React front ends and kind of assemble and run them, performantly in production, as well as allow you to develop them quickly and get your nice hot module reloading in development. The big thing that we've been focused on over the past 2 years, kind of before AI, has been integrations with e-commerce platforms as well. So Gadget stores, data that you've decided you want to keep, as well as it makes a copy of data in real time with a sync from Shopify. And that's really useful to get around kind of Shopify's API rate limits and to react to events in Shopify, like a product being created or an order, what have you. People have built a bunch of stuff with Gadget, specifically within the Shopify ecosystem, and it's working. I'm stoked that we have a number. I think I saw a couple paying customers on the call that are using Gadget to build Shopify apps effectively, and so that's exciting for me. The things that that Gadget tends to help with for building your Shopify app are things like OAuth and just kind of managing an install and all the kind of hoopla that Shopify makes you go through just to get access to Shopify data, syncing that product data, as I mentioned, say storing your own data. Like if you're building a storefront quiz app, you could store a list of quizzes or a list of quiz questions, so on and so forth. You can connect to your Gadget app from the Shopify storefront using that auto-generated API I mentioned. And then that app, if you built it in Gadget, is kind of hosted from birth, in that the instant you created it, it was live on the internet. There's no kind of deploy step where you now have to Dockerize it and figure out a server to run it on. It's kind of cloud native really deeply. The reason I mentioned this Shopify product quiz app is because it's a really good example of one of the things that changes with all the new API technologies that are out, right? I don't know if you've ever been to the biggest Shopify brands, like say Rihanna or a couple other makeup companies that I can think about. They all have this like very prominent quiz on their homepage that asks shoppers like, what is your skin oiliness like? What's your skin tone? And they're able to kind of refine the product catalog and make a recommendation for what product your average Rihanna shopper should purchase. And that quiz is like really clunky because some people sit in between different ranges, or they have kind of extra concerns, and they're really expensive to build. And so this is like why brick and mortar retail is great, is you can go ask the clerk at the store like, hey, I have this concern and this concern and this skin type, can you help make a recommendation for me? So that's something like a chatbot would be really good at, if you ask me, is kind of addressing a plain English ask for a product instead of forcing a user to go through a structured, maybe insensitive list of questions. So let's talk about what a large language model is and why it might actually be good at something like this. At its core, what an LLM is and what the GPT series of models from OpenAI are text predictors. So it is a way to say, given this like input string of text with eight words in a row, give me the ninth and do that properly. And so this is like a little GIF of how, if you repeat that process, you can kind of get GPT to generate, word after word after word, such that it can build you a whole sentence or a whole book or whatever. So you give it an input set of words, it predicts the next word. You take that next word and add it onto the input and run it again and get the next word and kind of rinse and repeat. And while really simple, if it picks the words right, it can exhibit really rich intelligence, right? Like in this case, I think this GIF is showing it repeating, a quote from a famous book. It's like, there's a lot of structure to all those words. It's picking the right words. It's actually repeating that quote. You know what I mean? It's not just picking kind of a random word or a word with a given probability. It has, I'm going to anthropomorphize for a second. It has an intention, right? It's like after a specific thought that it's using those words to get at. And so, like, I'm editorializing here a bit, but I would say this is the closest thing to like actually intelligent artificial intelligence that we've got. We have the image recognizers and segment things. We have the kind of image generators and whatever. But LLMs are the first sort of AI tool that I find you can really push to do something that like you need, say, a clerk in a storefront to do, as opposed to just kind of much more targeted, much more specific tasks. And then one other thing I just want to draw attention to is that LLMs really only take in text and return text right now. I think that's probably liable to change, but it's not JSON to JSON or a CSV or something like that. It's really just text. And so if you want to layer in kind of structured inputs, say from a database, or ask it for structured outputs, you actually have to like instruct it to do that in text and handle if it's able, if it screws up or if it ignores your instructions for whatever reason, like how that might work. So we'll talk about that in a minute. The other thing I want to draw attention to is that it's working. Like that actually intelligent artificial intelligence is, intoxicating for a lot of people, where it produced, the fastest growing consumer app of all time, 100 million users in 2 months. Like that's nuts, if you ask me. And so like, I think there's something really real here, right? That it's worth kind of investing time in learning how to work with these tools. I think it's a meaningful change for how we build software. So where we're at today, and I know this is changing really fast, but this is my take on where we're at today of what LLMs kind of can't do. You can only, as I said, you can only send in text and receive text. You can't send in sort of images or demand that it produce structured data. You can kind of ask it to produce text that might contain structured data. It's also hard to make them deterministic, which is to say, like, given the same input today and tomorrow, you might actually get different outputs both times. Or, if you make a tiny little tweak in the input, it could lead to wildly different output. And that's like a bit different than the programming that I think we're used to, where it's like, usually you have a function and when you run it, it does the same thing every time. It doesn't, decide to do it differently on Fridays. That's annoying. Another big limit is the amount of text you can send in. You can't exceed what's called the context length that the model that you're using kind of allows. And that's both the combination of the input length and the output length. And so, GPT-2, I think was, actually, I forget what it was. I know GPT-3 is around 4,000 words. GPT-4 is 8,000 words, and then they're releasing a 32,000 word kind of version. But that's still not, that's a lot, but it's not enough to say, like, send in, everything that's ever been written on a subject and summarize it. You kind of have to be selective in what you send in because there's a limit. Another kind of important aspect to them is that by themselves, the LLMs have no memory of what happened yesterday or what you just said a minute ago. It's really is just like, given this input, what's the next little bit of text that comes out? There's no like magical database in there that kind of remembers stuff. And we end up having to work around that a lot, right? That if you want to have state, you kind of need to send it in the input every time instead of expecting it to kind of recall. One more is that it's been trained on data from 2021. So that means it doesn't know about recent events. And so if you ask, ChatGPT about, say that a recent mayoral election in Ottawa, it just doesn't know that it happened and reports, incorrect facts. And then it also doesn't know itty bitty minute details that it wouldn't have come across when being trained. So like your personal details, it doesn't have to say unless you're a celebrity. Like certainly, say Shopify merchants, it doesn't have perfect recall of all their product descriptions or what changes they made since 2021 or what have you. It kind of knows a lot about everything, but not a maximum amount about every single thing, if that makes sense. And then the other thing is they can be used for evil, for sure. Like OpenAI has put a lot of work into aligning their eyes to be kind of refuse to be hurtful or refuse to be bigoted or refuse to generate copious amounts of spam, but their protections are not perfect by any means at all. I think I've seen countless ways to convince it to do evil stuff, and so I think it's like it's a spooky time right now where not everyone's sure this is just a good thing. So let's talk about how to overcome some of these limitations, and at least in the context of building apps for Gadget, what do we do about it not knowing about the merchant's catalog or not knowing all that much about e-commerce? Basically, what we're talking about is that input bit of text that we send into the LLM that it'll then predict the output for. It's like, what should that input be? And that's really the main element of control that we have as developers, is just kind of like, what arguments do we call the LLM with? What do we push at it? And that field, rapidly emerging field, is called prompt engineering. The prompt is the input that we send to it to prompt it to do something else. And we have to kind of craft that prompt to be most useful for what we're trying to do. So just for example, like Gadget has been working on a LLM powered chatbot for our docs. So if you go to docs.gadget.dev/chat, you can kind of ask questions of the Gadget documentation to kind of get, catered feedback on, whatever problem you're trying to solve. And this is an example of the prompt, or part of the prompt that we used the LLM to kind of help it do the thing that we wanted to do. So we say, okay, you are an assistant to Gadget. This is the role you're trying to play, and add a little bit of context about what Gadget is. And then we tell it what to expect in the input kind of further. And then we ask it to give us a specific format of output. And then we push in some documentation that might help a user answer their question. So all this to say is the LLM is kind of like by nature going to try to be helpful. But if you want it to do something specific, like say output markdown, or act as a representative of a company named Gadget, yeah, you have to tell it to do that. And it's not like an option in JavaScript where you pass a key name. Your name is : Gadget. You like instruct it to do so in English, which is like, it doesn't really feel like programming. You know what I mean? It feels like explaining to your like niece or nephew how to act. And I find that strange, but it's like, it really works. So one thing you may have heard about a whole bunch that pertains to LLMs is vector stores. And this is what I kind of want to focus on today, because I think it's kind of the main technique that just about everyone will have to use if they want to build more than a Twitter demo with an LLM. And what this is a way to overcome that limitation of the LLM doesn't know anything pre-21, and it doesn't know anything about the specifics of the problem you're trying to solve. In our case, let's say we're trying to build that product quiz system. The LLM doesn't know what products the merchant has for sale, and so we need to tell it. And the only way to tell it is by prompt engineering. So I'm going to describe the system, and then we're going to build it. And so don't stress out if it feels like a lot, or if there's kind of parts you don't quite get. We'll go through it in detail. But the gist of it is, because of the two things, because the context length is limited, and we're unable to pass all the information in the world in, and because we have to pass in, the information that we want it to know about that it doesn't know about intrinsically, we have kind of a relevance problem. We have to say, like, the LLM knows this, but it doesn't know that, and we can't send all of that in, and so we have to send only the bit of knowledge we have in that it can then use to answer the user's question. In the case of the Gadget docs, it's like Gadget has 60,000, 70,000 words of docs, and that's beyond GPT-4's 8K word limit. And so we have to kind of pick what of the docs is relevant to feed to the model alongside the user's query to help them answer the problem. If you squint, that's kind of a search problem. Like, you can imagine the same job that Google does when you search, like, how do I connect to Gadget, or how do I connect to Shopify in Google? Google goes off and finds like what's relevant to your query and shows it to you on the homepage. We have to do the same thing, where we go off and find what's relevant to a user's query from a database of content, then feed in only the relevant context into the LLM's kind of a prompt. The way that the community has kind of like, decided collectively to do this is with a thing called vector similarity. And what that is a way of comparing or assessing relevance and being like, the user's asking about this, does this document pertain to it? A way to assess that without doing straight up keyword matching. So a good example is, let's say a user is asking a chatbot, like, what will keep me dry in the rain? Like, the answer that they're searching for is something with the word umbrella, but the phrase, what will keep me dry in the rain, doesn't contain the word umbrella in it, right? So Google is smart, and they've spent, huge amounts of money building a big system that understands that when someone asks about rain, they're maybe asking about umbrellas as well. But if we were to just do like a straightforward keyword search, or if we just went to the database and said, give me all the documents that contain the word rain, we would never find the document that is just about umbrellas. And so what vector similarity is a system for assessing kind of conceptual similarity instead of straight up English, like just the token RAIN have the same letters in it as UMBR, so on and so forth. We're talking about sort of the meaning behind the words being similar as opposed to the actual characters of the words themselves. And so in summary, in order to feed in only the most relevant content to an LLM prompt, we need to go over a big list, find what's relevant, and we want to use a conceptual similarity so that the user doesn't have to use exactly the words they'd expect to find in the answer. I would like to build this to go through it kind of one step at a time. And to do that, we're going to use Gadget. I'm just going to switch which window I'm sharing here. Okay. That working okay? Yep, looks good. And we'll go to gadget.new. This is, like, I'm already logged into Gadget, so I'm just going to create a new app here. We'll call it AI Product Quiz Tutorial or Webinar. And so I now have a Gadget app. This app it has a URL. It's AI Product Quiz Webinar.gadget.app/edit. And this is kind of my editor environment where I'm able to use Gadget to begin building this application. If I kind of go look, it has logs where kind of the initial install of the dependencies are happening. It has this kind of URL where it exists out on the internet already. And I'm kind of ready to get going, building something kind of right off the bat here. The first thing I'm going to do is just wire up a straightforward call to an OpenAI API, so I can kind of show you, like, just from the basics, what an LLM would actually do for us. And to do that, I'm going to use a feature of Gadget called routes. What routes are is like a way to make my application respond to various HTTP URLs. So if I go here, and I'm just going to hit the plus button here, I'll do a get example.js. And what this is JavaScript code that powers my route handler. So if I do reply.send, hello world, I can then copy the URL for this route, which is, AI product quiz webinar -- development, which is my development environment / example. That example comes from the name of the route here. If I copy that and go to it here in my browser, I get hello world out. And so just to draw attention for a moment, what this is my app, fully productionized out on the internet, ready to go. It's in development still because I'm still working on it, but I didn't have to, set up Node locally. I didn't have to worry about if my Node version was right, or if NPM was running properly, or if my install was broken or anything like that. I didn't have to mess with SSL or domain names or hosting or whatever. I just have something ready to go, and kind of the first lines of code I can write are kind of relevant to the problem I'm trying to solve. So let's wire up a call to an LLM. The first thing I'm going to do is just install the OpenAI client. So I open Gadget's command palette here, and I'm going to run yarn add OpenAI. What this is going to do is go off and install the OpenAI package from NPM here. So this is their official NPM package that they kind of release from their GitHub that knows how to talk to their APIs. And that'll go off and do its thing. If I go look in package.json, now my OpenAI package is there. So that's good. Then what I can do is add a file called openai.js and just instantiate their client. I'm just going to copy in some code I prepared earlier so we don't have to watch me type. And what this is doing is, from that package I installed, importing the stuff that we need and then exporting a constant called OpenAI, which is an instance of their client. I need this API key to make calls to OpenAI, so I'm just going to stop sharing my screen for a second and paste that in so that y'all can't charge me $1 million for all this stuff. Hold on a moment. Okay. So here's my environment variable section in Gadget, where I've added OpenAI API key, and I put the encrypted value there. And then in my OpenAI JS file, I'm referencing that API key. Okay, and so then what I can do is go to a route. I'm just going to make a new route called get chat example.js. I'm going to paste in the route contents here. Okay, so what we're doing here is we have another kind of JavaScript function which implements another route. This time it'll be at a different URL, chat or /chat example. And what we're going to do is use the OpenAI client to create a chat completion. This is their word for, given this input, produce this output, but using kind of a more structured chat-based format for the input. And then we make the API called OpenAI. We get the text that the LLM generated. I just added a log statement here, and then we're going to send it to the browser. And so if I copy this URL, oh, sorry, one other thing. Where we're getting the input is from the query string of the request. So this is Gadget's way of feeding you kind of the stuff that's after the question mark in your browser. So I'm just going to copy this URL for this route, go over here, and what did I call it? Message is the key. So let's say message equals hello world. And then what we'll see is my browser is going to spin for a minute. But what it did is it went off and made an API called OpenAI, and this is what the chatbot kind of responded with. If I go look at my logs, we'll see that get got response from LLM, and there's my text response from the LLM. So it's working. Then I can ask like, what's the biggest tech company in Canada? It'll spin for a minute while it's thinking, and it's going to say, yeah, I don't have up-to-date information, but some of the notable ones are Shopify, BlackBerry, so on and so forth. So I think we're ready to make calls to OpenAI. It's working, and then it is smart enough to even tell us about some of those limitations I mentioned earlier, where it knows it doesn't know what the biggest thing is because it's been 2 years since it's training data. So I'm gonna pretend, or what I want to launch into is building that clerk-like kind of product assistant. So I want shoppers to be able to come to a Shopify store and type a question and get kind of answers that encourage them to purchase products from the product catalog that are right for them. The same kind of experience you'd get if you asked someone for help, in an department store. And so if I just use this example that we've written already, I want to show you that if I say like, what shoes would look good for spring? Let it think for a moment. It's going to reply with a super generic answer that doesn't have anything to do with any specific Shopify shoe merchant, right? It doesn't know that maybe I'm, on the Vans website or the Prada website or whatever. It's just going to give me this like super casual response that talks in like general terms. Ideally, a shopping assistant would actually push a given product or be like, here is a link to the thing, or like, do you want me to add it to your cart for you, right? We want something that would convert better than just this. And so here we get into that problem I mentioned, which is we need to feed in context that it doesn't have into the prompt, which is what we're going to do next. So what I'm going to do is connect this Gadget app to Shopify to suck in some product data from an example merchant. So I'm going to go to the connection screen. I'm going to go to Shopify. Oh, I'm going to create an app first. I'm just going to go to the Shopify's partners dashboard, and we will create a new app for testing here. We'll do AI product quiz webinar. And then I'm going to copy the kind of credentials from the Shopify partners dashboard into Gadget. And then I just want product data. So I'm going to filter down Gadget to read, or to ask for the read product scope. And I'm just going to sync over the product model. And then I will confirm that. And then I'm just going to copy stuff from Gadget that makes this app actually work back into the partners dashboard. Just close that. Copy this over to the partners dashboard. Okay, and now we have this Shopify app and this Gadget app kind of ready to talk to each other. And so I'm going to install my Shopify app on a test store. I have one prepared here, which is this data diversity test store. So what this is the kind of OAuth consent screen. So we're installing that Shopify app I just created, powered by Gadget, onto this Shopify store. I'm going to click install here. And then we see an embedded UI should show up here. And this is my Gadget app's front end. So if I look, this is the Gadget logo. If I look here, I can open shoppage.jsx, which is the kind of Gadget front end code that's powering this experience right here. This would be where, say, for our AI product quiz, you'd build stuff that would manage, like that. It would give the merchant control over how the shop assistant worked. Like, say they want to say, don't use these products. We don't want to sell them. We're out of stock or something. Or use these products. These are more important. I'm not going to work on the front end for the merchant today. I'm just going to work on the LLM part. In any case, let me show you what happened in my Gadget app when I completed that installation process. So I now have this Shopify connection, and what I'm looking at is a dashboard here. It shows me my connection is able to read products from Shopify. It's using this API version. Then I have one shop installed here. And if I click on that, I see, okay, this is the shop that installed my Gadget app. I've got API scopes. I'm listening to webhooks. And so this is something that Gadget manages automatically for you when you use Gadget and Shopify together, is the kind of webhook registration and reception process. And then I haven't yet synced my Shopify data. What that means is Gadget stores a copy of the Shopify data in your Gadget apps database. And we'll get to why that's super important in a minute, but the main use case for that is just dodging the Shopify rate limits, where they're super restrictive on how often you're able to make calls to them. And so syncing the data out allows you to call it and query it as frequently and as strangely as you might want. So I'm just going to click the sync button here, and then I'll go over to my logs in my app, and what we'll see is the app going off and working hard, receiving a whole bunch of data from this data diversity test Shopify shop here. If you look, I have a whole bunch of products I've created in here that are all just tests, but they all have different descriptions and stuff, and so it's a good set of content for us to use to test out this quiz. Okay, so I'm going to go look at the Shopify product model for a moment and look at the data that's stored, and we'll see that sync is syncing in a whole bunch of those products. And I have the IDs, I have the category, I have the body, which is the description that we're probably going to feed into the LLM, the handle, all the fields from Shopify over here ready for me to work with. Excuse me. So what I'd like to do now is feed this product data into the prompt that I'm sending the LLM so that it can use it to then answer, say, a given user's question. So right now we're only sending in the user's message, but what I'd like to do is kind of merge their question with product descriptions that I fetch from my Gadget database. So I'm just going to paste in a new version of this route here, and we'll go through it line by line. First off, we're still doing that create chat completion thing, but instead of just sending in request.query.message, we're sending in this like kind of whole string. And what this whole string says is we're going to list a bunch of product descriptions and then say user input and pass the input. So this is baby's first prompt engineered, where it's more than just what the user handed us. It's decorated with some extra data. The other big change here is that we're passing what's called a system prompt. And a system prompt is kind of a powerful feature that they added with this create chat completion API. It lets us tell the LLM how we want it to behave. So I'll go through this kind of line by line. First off, we tell it we want it to act as a shopping assistant and kind of embody that character. The next thing we say is you should expect to be given a bunch of product descriptions. Oh, I'm going to not send in the IDs. I'm just going to send in the product title and the description of the products that are available for sale. And then I'm going to give it some instructions about what I want to do. I want it to reply to the user's input, suggesting a product to buy. And then I add this little addendum that's like, if they ask about, say, the biggest tech company in Canada, I don't want my shopping assistant to help with general purpose questions. I just want it to help with shopping. And so for our completion response, we're now sending in the system message and this kind of decorated user message where we build this whole thing. What I'm going to do is just send in the first 10 product descriptions. And so I'm going to ask my Gadget apps database to load up, the first 10 products. I'm going to build a string that just says title, the title, description, the description. And then I'm going to send that off to the OpenAI API. I'm going to get the response like we were getting last time. I'm going to log it, and then I'm going to send that response to the browser. So if I go over to the chat example route again, and I say message equals what shoes would look good in spring, it's going to go off and think for a minute and do its whole thing. If I go look at the logs, I see that sending descriptions with length thing. And then we get a much better output here, which says, based on your input, I would recommend checking out the Vans Authentic, yada, yada. And if we look in here, search Vans Authentic, which one did it suggest? Low Pro Burgundy White. This one. I don't know if y'all agree, but that seems like an okay springy shoe. You know what I mean? So what we've done now is engineered a prompt to convince the LLM to do something kind of more useful for us beyond just answering questions about its intrinsic knowledge. The issue is, with what I've done so far, the first 10 here means that this LLM's only able to recommend out of the first 10 products in my catalog. And if I do something like this, where I say first 250, because I want to recommend more, and I go back and run the same query, I get an error. If I go into my logs here, error making request to OpenAI, get a status code 400. And that's OpenAI's not very useful way of saying you sent in too much text. And the reason that that's happening is, my first 250 product descriptions, or frankly, all the product descriptions that I'd like to send in, sum up to be more text than OpenAI is willing to process, than their machine learning models actually support. And so here we arrive at that relevancy problem, where instead of just blindly sending in some of the product data or trying to cram it all in and hope that it fits, what we want to do is pick some of the products that we think are relevant, send as many of them in as we can, and have the LLM do the hard work of choosing among them based on their descriptions which ones seem relevant to the user's input. And so this is why we call it a search, is we're searching for the relevant product descriptions to send in that will power kind of a large but not too large prompt for the LLM to then process. So the way to do this search in Gadget is using that vector tooling that I was mentioning. What we're going to do is, basically, when we search for the products here, we need some way to say, get me sort by the most relevant products to the user. And Gadget has support for this in the form of the vector field type. So I'm just going to go back to my slides for 1 second and pull up that diagram again. Just to give you a brief kind of overview of what we're about to do. What we need to do is when we search by vector similarity, we need to kind of search over an already generated kind of corpus of text. We could do that with a keyword search, but instead we're going to use this vector search, and that's what's going to get us that kind of conceptual search, which will interpret the word spring to mean things like light or airy or cool. And the way that the whole LLM community has kind of decided to do that is by using what's called vector embeddings of text. So instead of searching text against text, we transform each of the bits of text that we care about, like all the stored product descriptions and the user's input, into a vector, which is just a big ass list of numbers. And then we see that the numbers that are the closest together will be conceptually similar. The way that it works is we take all the descriptions that we have for all the products, we embed them, which is basically means hit the OpenAI API with the text to get back a big number, which is a vector. We store those vectors, and then when we want to do a search, we take the user's input, which comes in as text, we embed it as well to turn it into a vector, then we search for the vectors in the database that are most similar to the user's input. So instead of kind of searching text to text, apples to apples, we turn both pieces of text into oranges, which are vectors, which can be searched for semantic similarity. Let's do it. So the first thing I'm going to do is go back to my Shopify product model here. You'll see I have all these fields that are all the stuff that Shopify provided, but I'm going to add a field of my own and call it description embedding. And I'm going to set it to be a vector field type. So I have kind of a new column, if you will, on this Shopify product table that now I'm able to kind of read and write and set data on. And then inside the Shopify product model, this is the implementation of the create action, which is the thing that kind of handles the product create webhook from Shopify. Right now, it just persists that data to the database, but I want to do one extra thing, which is compute that embedding of the product. And so in my onCreateSuccess.js file, which is the kind of handler for the create action, I'm going to paste in some code here. Oops. That will populate this embedding field. So what we say is, if the product doesn't already have an embedding, or if the body has changed, in that we want to re-embed, we're going to make a call to a different OpenAI API, which is this embedding thing. We're going to pass in the records, the product description, which the Shopify calls the field body as the input. So this is text, and then we get back a kind of vector from the API call that we make. We log that we got an embedding, and then what we do is we save the vector that we got back from OpenAI in that description embedding column. So if I go look at my product data, I see that description embedding is null for all my products because I already synced them and I just added my column. So what I'm going to do is actually delete them. I no longer have any products, and I'm going to go back and resync Shopify by going to connections and clicking that sync button again. And what this will do is it'll go out and fetch all the products again. And then we'll see we get a lot of these got product embedding logs because we're hitting the OpenAI API. And if we go back to the product model and click on data, we'll see over our description embedding column, we now have these vectors. And if I click this, I'll show you what a vector actually looks like. It's total gobbledygook, right? It's like absolute computer nonsense of just a huge number or a huge list of numbers. What this is, though, is to us as humans totally irrelevant. But the reason why it's picked, or the OpenAI API picked all these very specific numbers, is it occupies kind of a point in the vector space. It's very close to points that are semantically similar. So if this, if that Shopify product we were looking at happens to be a springy product, like this vector will be close to the vector for the word spring as well. Okay, so going back to my chat example route here, what we now need to do is use the vectors in our product find many call to find the products that have the most similar vector to what we want. So I'm just going to paste in a new version of this route, and we will go through it again. So still got our system message up at the top, still using that request.query.message to get the input, but this time for the user's input, we're also going to embed it. That's that whole apples to apples or oranges to oranges thing. We're going to convert both the descriptions to vectors and the user's input to vectors. So we get a vector, here I'll just call this vector, from the user's input, where we send in that input from the query message to the same embedding API. We get back a vector. And then now we're going to find the first 20 products where we sort them by vector similarity between their description embedding and the user's vector. So this is this piece here where we're searching by vector similarity to only return the most relevant products to the user's input. We still do the same thing where we build that big string, but the description's length is going to be much smaller now because it's only 20 products, but it's 20 products that are actually relevant to the user's question. We then fire off the completion to OpenAI again, where we say, there's the products with the descriptions, only the relevant ones. Here's the user's input, and we send the response. And so now I'm going to say what shoes would look good in spring again. We'll let it think for a minute, and we should get back, a suggestion for a product to purchase that is based on that vector similarity and reference. So variety of styles, a sleeveless dress, that sounds pretty springy to me, or a buckstrap heel, great. And then if you're looking for something casual, you can try these products that, I don't know if those are springy or not, but I believe it. So we've now built like a shopping assistant. There's a lot of kind of stuff to build where we have to make a UI for this on the storefront. We have to make a UI for the merchant to edit it. But this is kind of the core of what AI app development is today, is like figuring out how to send in the right text to the chatbot that kind of has the most relevant context without going over the limit. And we've done that. So I have a lot more to show that kind of builds on this, but I'd like to maybe stop for a moment and just take some questions and make sure that this is clear kind of where we've gotten to before kind of making it more complicated. Emma, do you have a few that we should go through, or does anyone want to just share a couple in the chat?
We do have just one for, excuse me, in production, you'd want to compute embeddings of only new products, correct? i.e. only once per product?
Absolutely, yeah. The each of those API calls to OpenAI costs something, right? Like it's not very much for the embedding APIs, but yeah, you'd only want to do it once. So that's why we do the embedding kind of on the webhook for the Shopify product, which is to say, like only when it changes do we re-embed. We like a more naive approach would be to like each time a user asks a question, we go embed all the products and then kind of answer their questions. But no, we're only doing it once because we're doing it kind of when the product changes, and then we're storing it on the product to then search for it later. Another small optimization around that is this thing here, which says we're only going to run this embedding stuff if the product doesn't already have an embedding, or if its description changed such that we want to re-embed it. Great.
Does that answer your question, Gustavo? Awesome. Okay. Anyone else have any questions with this? Okay,
great.
We're good.
Okay, cool. So what I would like to do is just kind of show you how you can wrap this up in a little bit nicer of an experience. You'll notice like when I refresh here, it kind of sucks to just sit and look at a spinner. And so I want to show you that a couple things. We can build like a UI around this with Gadget's front-end hosting tooling. And we could build a streaming system that kind of like pushes the response out kind of a word at a time as it's made available on the back end. So what I'd like to do is do the front end bit first, and then we have time, we'll do the streaming thing. So when I installed my Shopify connection, Gadget set up that front end that you saw in the Shopify admin. If I go click on this AI product quiz webinar and inspect here, we'll see this is like an iframe to AI product quiz webinar development.gadget.app. This is my content being hosted within Shopify. I don't, just for the purposes of a demonstration, I don't really want to use this because I want to kind of focus on the merchant, or sorry, the shopper experience. And so I'm just going to replace a bit of the code that Gadget generated for that embedded app just for a minute. This main.jsx is kind of the React entry point that actually like renders the React app. I'm just going to replace that with an unshoppified provider here. And then I'm going to paste in an example app that has a little less Shopify stuff. And then what I'm going to do is open up the app front end. So now we're outside of the embedded app. And so I'm just going to close this data diversity tab, and we're just going to look at this kind of nasty UI that I'm building here. One thing I'm just going to do really quick is make that text area look a bit nicer. So I can just go, what is it, padding, bottom. So one thing I want to show you is that without me doing anything, this has kind of hot module reloaded and showed me the kind of new version of my app. So if I say like, background color red, and I just change tabs, or I guess you can't set here, how about border? There's my red border without me refreshing or having to reload the page. And if I show us the app, where did it go? This page. I just want to show you the React code that we can use to actually like make a call to our Gadget app. Just for kind of good form, I'm going to change this route to be a post. And the reason I'm going to do that is because I want to kind of make requests to it with an actual form. And then I'm going to use Gadget's use fetch hook to make a request to that /chat example with the post method. And then the one other thing that I need to change is change this to asking for the message from the body instead of the query, because now we're going to send it from the body. One other small little addendum is that Gadget supports kind of like schema validation. where we can say that, every request to this route needs to be sent to body. So that's what this does. That's all documented in the docs. And then if I go to my app here, okay, so we're doing use fetch. We're sending it to that chat example endpoint. We're going to send it with a post. We're going to send content type JSON. And then when we send it, we're going to do a body of JSON stringify with a message, the user's message. Then that message is all managed with this React text area to store the state. What useFetch returns us is kind of this mutation function to actually do the send when the form submits, as well as the data, the fetching state, and the error of if that request has been sent. So when I say Gadget is a full stack framework, this is kind of what I'm trying to get at, is that it's not just a backend data store and not just an API. We kind of add these sort of facilities for hosting your React application and interacting with your backend application in that way. So I'm just going to open the network tab here. Let's say, oops, what will look good in the spring? Hit the ask button. If I look at my network tab here, we see there's a chat example, request here. And this is like exactly what I was fighting with just before I got on the call here, is I'm missing some step to get the conversion from the get to post in order, but I'm not going to make you sit here and watch me debug it. Anyways, what I wanted to show is that we're able to kind of pretty easily put together like a test bench UI that will make requests for this stuff. And if we go to the kind of main app that I've been working on that does this, I called it Wise Buy. ChatGPT generated that for me for a shopping assistant app. If we go to this one, I've kind of gone through and actually built out the this basic thing that we were talking about, as well as one that streams. So if I say what would look good in spring here, we're able to kind of get a feed of the text as it comes in. And I think that's like a much better user experience, if you ask me, so that the user can kind of read as it goes. It's also what ChatGPT themselves have decided to do. And this specific streaming thing is like really, really annoying. Riley's going to publish a tutorial on the Gadget docs like later today, actually, that describes exactly how to do this. But it's like just so much hoopla to set up because OpenAI makes the API really hard to work with. But I'm really glad that we can kind of provide all y'all with exactly the kind of template of code that makes doing the streaming bit super duper easy. Yeah, the kind of key piece to that is in the streaming chat example. That use fetch hook that I was mentioning that makes kind of a call to an endpoint has the stream true option, which just makes it so you don't have to really care about all the intricacies of how that's happening. We just get the stream back, and you're able to kind of set the reply with each new element of the stream that comes back. Again, all that's kind of in the tutorial, and I don't really expect you to remember all of it, but I just want to point out that it's possible and something that I think makes a big difference. The final thing that I just wanted to talk about really quickly before we kind of run out of time is LangChain. So you might have noticed that there's kind of like a few different steps to that pipeline where we go out and we query the vector database for what the content that's available is. We feed in into a template of the prompt of like what all that text and how it should be arranged is. We get the response from the LLM. LangChain is kind of an emerging JavaScript and Python library that makes organizing all those steps like a lot easier. And so in the kind of fully realized versions of these apps, you can use a bunch of facilities from LangChain instead of from OpenAI to begin making this thing more robust. So a good example is I want my system to not only just give me like a text response with the product title in it, but actually like give me the ID of the product so that I can like send the user to that page. So if I ask what would look good in spring, hit the ask button. Oh, I might have been cutting this just before we got on. I would like my text response in addition to kind of a handle, and so that I can like build a link to that product in the storefront. And if you look here, if I click this, oops, I screwed up the link there, but if I go to that, whatever. I'm able to get structured data back from the LLM instead of just text. And so LangChain, it's like a complicated topic for how to actually do that, but LangChain is a tool that has this structured output parser thing that says, I want you to return to me a answer, which is like a string text, as well as a list of product IDs that you think the person should buy. It has tools for templating your prompt as well. So you can say like, I want to fill in the products here. I want to add the instructions for how to format your output here. I want to do that. It gets kind of further on from there, but what I've found is kind of using the raw OpenAI API wrapper package really just is great for like single calls. But if you want to kind of productionize the thing where you want to limit your context length, you want structured input or output, you want to make other tools available to your LLM, the LangChain package is kind of how you get serious about this, if that makes sense. So in the next couple of weeks, we're going to be publishing a utility library for using LangChain with Gadget. So you can look forward to that. You don't need to use it, but like for the kind of productionized chatbot thing that we built internally at Gadget, I found LangChain really made a huge difference. And okay, I think that's it. Maybe we'll just jump into the questions. Thanks so much for listening. A lot of people. Right. So if you are building I'm just reading this first question here. If you're building a Shopify shop that kind of has a backend Gadget app, Gadget will provide you the tools for building the merchant-facing experience. That is the kind of in admin privileged kind of context where the merchant wants to administer, the rules of how the quiz or whatever. For actual shoppers to take the quiz, we recommend Shopify's new features called theme extensions and app blocks. So it used to be that, yes, you'd have to introduce custom JS or Liquid to change their stores, but now apps can kind of insert chunks into the theme that the merchant's able to move around without having to get technical and break their theme. Those are called extensions. And so, yes, what I would suggest is using the Shopify's kind of existing stuff for building theme changes. Okay, next question is ways to integrate Python libs with JS. Great question. So Gadget is currently JavaScript only. We don't support Python. That's okay though, if you ask me, because LangChain has a JavaScript implementation in addition to a Python implementation. I think if you're doing like hardcore machine learning development where you're like building the models, I wouldn't recommend JavaScript, but Gadget's more focused on the actual like serving of the model or sort of commercializing some application of it. And I think JavaScript's like the right tool for the job there. So to technically answer the question, no, you can't just call the Python straight from JS, but OpenAI's API works great from JS and the LangChain lib works great in JS as well. What would be the simplest way to have an interface to view and adjust the AI model? This is a good question. I'm going to interpret this as like I want to kind of try it out behind the scenes to make sure that I trust it before kind of going live. If you're talking about how should a customer ask questions of the AI, I think that's the checkout extension answer. But for you to kind of work with it, what I would suggest is building kind of a UI the same way we did there, which is like adding new React components to your Gadget app that allows you to test it. There's kind of an emerging, like this is also new that the tooling really isn't that great, but weights and biases. This is like a platform that a lot of different machine learning developers use to kind of like instrument and understand the performance of their like machine learning models. And they just introduced this new kind of like LLM prompting specific product called weights and bias prompts. So we haven't integrated this. I've never used it. I can't tell you if it's good or not, but it excites me that people are starting to build awesome dashboards for managing their LLM prompts. Q4, is it profitable to build AI products with Gadget? Like Yeah. Yeah, it is. I feel like, you probably shouldn't just take my word for it, but we had like one customer of Gadget build a AI powered product description generator in like a week, and they got featured on the App Store like shortly after. And I think they did like really, really well with, a week's work to build an app, which is, if you ask me, like really short. So I think they were pretty pleased with that and definitely found it profitable. I think it's like a hot space, you know what I mean? So there's definitely going to be some other folks like trying to do the same thing. But I think if you have, at all a unique spin, it's also new that the getting is good right now, if you ask me.
Yeah, I would agree. The app Harry's referring to is Auto.
Oh, yeah.
OTTO. And last time they shared with us, they were saying that they had over 500 installs because they were able to get it to market so quickly. We do have a case study on that on our site, which I'm happy to share with everybody. But I wanted to say we do have one more question that for some reason just isn't showing up on the slide. What would you recommend to use in order to stay within the OpenAI rate limits? For example, GPT 3.5 is at 3,500 requests per minute on paid accounts.
Yeah. Honestly, I don't think there's any way around it other than like load balancing across API accounts. So we haven't hit that with our use of the models internally yet, where we aren't like overdoing it. But I think you basically just have to provision multiple accounts. Like you're able to add, retries, right? And it's one thing that the OpenAI library is missing, which I find really annoying, so that it won't just like try again a little while later, but that does kind of slow down the user experience. So I think you kind of have to like dodge the rate limit. For what it's worth, I know that, if you're able to use any of the other kind of LLM APIs, some of them have much more forgiving rate limits, like the Hugging Face stuff. And I think Cohere is actually better too. They're all trying to find some way to get you to use them instead of OpenAI. And so they're trying to be like nicer. So you could look into OpenAI alternatives as well. Sweet.
Any other questions? Okay. We're still open for a few minutes if you guys have any last minute additions. But if not, I'll leave you guys a minute to ask them. Oh, will the code be shared somewhere?
Yeah, absolutely. So like I can share the app I just made for sure. Riley's going to publish kind of a little bit more polished tutorial that has a little bit better commentary, and it's actually a little bit more productionized, which is to say it handles things like those retries and whatever. So I think you can expect that in the next day or two. It'll be called the AI product quiz tutorial.
Yeah, so that I think either tomorrow or early next week, but it's coming.
Oh, okay.
Yeah.
Great. Sweet.
Awesome. Yeah, so again, we will be sharing the recording. It'll be available by email in our Discord and on the official hackathon page. I definitely encourage everyone to join the Discord. There's a great community in there, as well as just like all of the Gadget staff. So if you do want to connect with anybody, we do have one more question. Similar question about monitoring your AI app on production. What do you recommend to instrument your Gadget app?
Great question. Like so far, I haven't found a need for anything really more than just Sentry. So like that's what we use for error tracking in production for Gadget, as well as many of our customers. We have a built-in Sentry connection, which is kind of like we'll send errors off to Sentry and lets you build alerts and that kind of thing. Gadget has that built-in logger as well. I think like the weirdness with LLMs changes the game a little bit, where it's like having 60-second requests starts to become normal, because if it takes that long for the LLM to generate the response, it takes that long. And I think that the observability vendors haven't really like wrapped their heads around that yet. But yeah, I don't think we have any unique needs beyond the kind of normal error tracking tools of the day.
Awesome.
Great. Thanks so much for your questions, everyone. And thanks for listening.
Have a great rest of your day. Bye, everyone.